nice example here now for how this would actually apply in real life. Example 3. We're going to say if f of x equals positive square root of x, graph y equals 2f 2x plus 3 plus 4. Okay, so this is a type of question you'll see on your test, just like the last one could be too. This was actually on your assignment. Probably, hopefully the numbers are different. Okay, but this is very close to one that's on your assignment as well. Okay, how is this one different than our last example? Is that really good? Well, I see one big difference. How's this different than our last example? Yeah, last time we were given the points, this time we weren't. Can anyone give me a suggestion on how I might get points for this graph? Yes? Yeah, exactly. So I'm going to say just pick 4 points for x. Okay, so when I do this, I'm going to be smart about my points though, okay? I'm going to choose 0. And see, because the square root of 0 is 0. I'm also conveniently going to choose 1 because the square root of 1 is 1. What would the next point be that I'm going to choose? Think carefully. Very good, David. Why would you choose 4? 4 works out to be 2. Okay, the problem is if I were to choose 2 for my x, the y would always be root 2, and that's going to be messy to deal with. You can still do it, right? But it's, you see what I'm saying? It's going to be very difficult. So David's correct. We'll choose probably 4 and 2 would be nice. So another David, give me a next number that might be good. 9 would be excellent, okay? So just like that, I've made the graph of positive square root of x. So are we okay on where those 4 numbers came from? Most people? Okay, and you want to sort of use numbers that make sense, right? Okay, can I leave this to you for a few minutes to try this yourselves? Yes. I want you guys to try the 4 transformation right now. Roger, question for this number here. Because 4 and I'll probably say to you guys how many points to pick, okay, for that. Just it'll be the same pattern, like square root of x, whether I do this or I do this, it's still the same shape, yeah, right? But just it's generally 4 is the number that we use mostly here. Pause. Please stop me. Okay, but I'm going to go through this as quickly as I can. We're going to start with 2f of x. Actually, I'm not going to go that fast. First thing, what does the 2 mean, please, on 2f of x? Yeah, multiply y by 2. Okay, so it's going to be 0 and 0, 1 and 2, 4 and 4, and 9 and 6. All right, 2f of 2x. Madison, what does that mean, please?
You have to divide the x by 2.
Good. That turns to be 0 and 0, 1/2 and 2, 2 and 4, and 9 over 2, 6. 2f of 2x plus 3. Brooke, what does that x plus 3 mean, please? Right on. So that turns into negative 3 and 0. What is that? Negative 5 over 2, 2, negative 1 and 4, and 3 over 2 and 6. Is that right? I think so. All right, and Julia, what does this plus 4 at the end mean? Very good. This is going to be negative 3 and 4, negative 5 over 2 and 6, negative 1 and 8, and 3 over 2 and 10. Okay, are we feeling relatively okay about that? Right there. If you do decimals, that's okay, but you're gonna lose half a mark on your test if you do. Okay, so just accept that. That's gonna have to use decimal. Okay. And all's well. We're good. Looking happy as ever.
What if we use decimals for the percentage convert to a fraction?
No, get away from using decimals because, as I keep saying, in math, very soon you're gonna learn the numbers. Like very, very soon. If anyone here is planning on going into university, you will not see a number in university math ever. Okay, right? So even in calculus and stuff, and advanced functions, most equations will just have variables in them and not numbers. So get away from changing things to decimals.
How do you solve it?
You don't. You're getting more equations. Start an equation, you get bigger equations. Then you get smaller equations. Then you get bigger equations. Then you get smaller equations.
I was looking at real estate course last night and I didn't see a single fact.
Really? Alright. No, I don't believe you. Here we go. Let's make a graph here. Now the little twist I put on this, I said domain and range 2. There's one thing I didn't actually talk about for our table of values. Why did I start at 0 for my x here? Why did I choose 0, 0 as my first point? It's easy, yes. Why also? Yeah, sorry? Sort of, okay. We don't really know the word asymptote, so I'm not going to call it that yet, though, but sort of. Yeah, it's the first number. Here we go, guys. Can I please talk? It's the first number that actually works. What happens when we type in the square root of -1? Well, it doesn't go, right? You know what I mean? So there's nothing that can work for an x value less than 0. In the same way, then, there's going to be nothing that's going to be able to work with less than -3 after all the transformations. So I'll do it when we graph. I'll show you as it works out here, hopefully. We're going to choose a suitable scale. I'm going to embarrass Ben here one more time here. Ben, you did a good job on your quiz. I said what the when I looked at some of your graph, but yet you did a good job on your scale. What Ben did is he wrote down the scale underneath. He said that every box was equal to 1/2 or 1/3 or whatever it happened to be, and that's a good thing to do. In this case, I'm going to choose my x's to be every 1/2. Why does it make sense that my x's are every 1/2? Because I have fractions of halves, right? So I've got to get from 4 to 10. I'm going to make a graph that I go to -3. So I'm probably going to go something like this. And something like this. Okay. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. -1, -2, -3, 1, 2, 3, x and y. There's a nice graph. That took about 20 seconds, okay, to do, and that's the graph. -3 and 4 is going to be up here someplace. -5 over 2 and 6 is going to be here someplace. -1 and 8 is going to be way up here someplace. And 3 over 2 and 10 is going to be here someplace. We okay on that? Right there? We're just going to connect the dots. Sort of like this. And the graph is just going to go over in that direction. 2f of 2x plus 3. I think I'm also going to just draw the square root graph here, just to, I can't really do it this way. That's the regular square root graph, looks something like that. Okay, any questions on the graph before I keep moving here? You guys are way too kind. Take a moment. This isn't easy. This is the first time I've seen a square root graph. This isn't easy. I can't believe not one person was a question. Yes?
Where's that green thing come from? Yeah.
Where that green thing come from? Oh, okay, good question. This is just the square root of x. That's what this one is.
Oh.
That's just so you can see what the original graph looked like and then the transformation.
Would you have to do
No, you don't have to. Just for visualization here, okay? So this, I want this to help for our domain and range. If if you look at the original graph, the x values only are positive and the y values are only positive. Okay. For this one, we're going to give you a second to scribble that down, and then we'll keep going from here. Are we okay on where most of the stuff came from so far? No comments, that's okay. Colton, how's life? I can't help you, you're right in my field of vision when I look out like this, just right between there. Ben too, that's what we're trying to do, Ben. You're in my field of vision, you're in my field of vision. You too, nice, good luck, stuff like square, there's easy work to contact. Okay, can I get someone who's brave to try the domain and range for this monstrous graph?
The red one.
The red one, please. Amy, go.
Domain is equal to squiggly brackets.
Yeah.
Line. -3.
Yeah.
Greater than or equal to.
Okay. Yeah.
And x is the number.
Yeah. So yeah, you were like this. The 3 is.
Less than.
Yeah. I probably write this as x is greater than or equal to 3. That's why I write it, but you can write it either way. Okay. So x, if you take a look, is greater than or equal to -3, and x is a real number. Okay. Now, someone came in here at lunch, I will not say who it was, and said that was the hardest part of them in this course so far, was saying to get bigger or smaller. I'll show you how to do this. Domain is your x value. So here's a -3. -2 works, this is bigger. We're going in a positive direction. These are bigger. So you're just going to say x is bigger than -3. If you still cannot get the symbols right, bigger than or smaller than, write down there bracket bigger. Okay, so I'll try, I'll at least know what you'll aim at and give you half a mark. Okay, for that. Can I get someone who's brave? Thank you very much for being the domain. Can I get someone who's brave to do the range for me, please, for the grain graph? Albert, go.
Range equals bracket y.
Yeah.
Y is greater than 4.
Yeah, greater than or equal to 4. Yeah. How's the y? So again, just looking at this again, look at the graph. Greater than -3, and then greater than 4. The only question no one's asked, how do I know this goes on forever like this? Okay, right, because there's an arrow on it, because I told you guys square root of x, I kept on picking numbers. Okay, right, but if on your test you didn't know you just went from here to here, I probably wouldn't have an issue because the graph, the table only goes from there to there. Does that make sense? Okay, right? I'm telling you that. Oh, well, that's because. Number one reason I'm a math teacher, okay, but the second reason for that is that if you look at the square root values, right, you can't take on my original function. I couldn't take the square root of a -1 or -2 or -3 for square root of x. So this is your starting value. So because of that, this is also your starting value. So I'm going to go in one direction. Okay. So you got to use a little intuition or whatever you want to call it. I'm going to hit pause, and then we're going to. Generally,